All right, ladies and gentlemen, welcome back to the 2017 Calculus BC multiple choice exam. So for this part, we're going to be working on 15 questions. We have 45 minutes. The graphic calculator is required, but I don't have one with me. So if a problem actually requires the calculator, I'll give you my ideas on how to start it, what to do. But I'm not going to be able to do it. Okay, number 76. We have a twice differentiable function. Which of the following properties guarantees that f has a relative minimum? Well, before even looking at the options, having a relative minimum, we're going to have to take the function f, find the derivative, set it equal to 0, and then from there, whatever we get, we're going to have to test it in the number line, right? And if it's going to be a minimum, we have to get the derivative is negative and then positive. So option A is not the answer because even though it's a critical point, it could be a maximum or it could be neither. The derivative is 0 and the second derivative is negative. That would imply that f of x is concave down, but that would give us a maximum. The derivative is 0 and the second derivative is positive. F is concave up. So yes, that would be a minimum. The derivative is positive for x is less than c, and the derivative is negative for x is greater than c. That's actually talking about a maximum. So there you have it. If h of 5 equals pi, what's h of 2? So in order for us to do h of 2, we're going to have to do the integral from 5 to 2 of the derivative. And don't forget to add your initial condition. And like I said, I don't have a calculator with me, so this is as far as I can take you. Just plug it in, and one of those will be your answers. The continuous function f is positive, and it has a domain greater than 0. If the asymptotes of the graph are x equals 0 and y equals 2, ooh, let's sketch it out. If the asymptotes of the graph are x equals 0, so and x equals 2, or y equals 2, sorry, which of the following statements must be true? Whenever you guys have asymptotes, the graphs basically follow the asymptotes. So these two asymptotes create 4 regions, which means that we have 4 potential graphs. This graph would be one possible scenario. This would be another possible scenario. A third. And a fourth. Once again, because the graphs will follow the asymptotes. These are just possibilities. And it doesn't mean we have all 4 of them at the same time. So let's just check the options. The limit as x approaches 0 from the right side is infinity. So if I start approaching 0 from the right side, the graph does indeed go up. So that part it actually checks off. The limit as x approaches 2 is infinity. But if I start approaching 2, I don't know where 2 is, but it's somewhere here. And if I start approaching 2, let's just say it's here, that limit does not look like it's infinity to me. That limit is a y value, whatever y value this happens to be. So that part right there is not true. So automatically this part is also not true. The limit as x approaches. Okay, so there we go. B and A are not answers. Okay, recycling the work that I did in part A, I know that this part is true. Okay. The limit as x approaches 0 from the right side is true. No, we said the limit is infinity, right? If you approach 0 from the right side, the graph starts going higher and higher and higher and higher. So the limit is infinity, not 2. That one's gone, leaving us with option C. And just to check it off, let's try the last condition. The limit of 6 approaches infinity. So when you go to infinity, we get closer and closer to the y value too. So that is good. Okay. We have the graph of f. We have 3 line segments. G of x is the integral from 2 to x. What is the maximum value? Okay. So if I want to find a maximum value for g, the first thing I'm going to do is I'm going to go ahead and take my derivative, set it equal to 0, and figure out where the function is equal to 0. Since I'm looking at the graph of f, my critical point is going to happen at x equals 3. To find the maximum, I have to check the critical points and the endpoints. So let's go ahead and start by checking the critical point 3. The integral from 2 to 3. The integral from 2 to 3 is a triangle, so we have 1/2 base times height, which is 1. Let's check the endpoints. The g of 0, which is the integral from 2 to 0. Now, before I even do the work, I can already tell you this is not going to be the maximum, because I'm going to calculate the area starting from 2 and going backwards to 0. This area right here is positive, but because I'm integrating backwards, that's going to count as negative area. Watch. The integral from 0 to 2 is quadrilateral. The base is 2, the height is 2, the value is -4. So you see, it was not a maximum. Now we can try the endpoint, 6. So even though I'm supposed to evaluate the endpoint 6, starting from 2, I can already tell you that this answer will not be a maximum, because the positive area is such a little bit, it's such a small quantity, but the negative area is significantly more, so then my value is going to end up being negative. And if we do it, we're going to get 1/2 base times height minus, that's a trapezoid, so the trapezoid right here, the length of A is 2, the length of B is 3, divided by 2. The height of the trapezoid is 2. I'm not going to put -2 since I already wrote a negative in the front. And this becomes -4. So the maximum value happens at x equals 3, and it's 1. Okay. We have the position of an object, and we want to find the speed of the particle at t is equal to 0. Well, speed is the square root of x prime of t squared plus y prime of t squared. Which means, and again, we have the calculator for this, right? So my derivative for x is going to be 5 cosine of pi t times pi. Don't forget to use the chain rule. Oh, you know what? We don't even have to do this by hand. I mean, we could. The derivative of y is 2 times 2t minus 1 times 2. And all of that's going to be squared. And then you plug in the 2. Or, sorry, the 0. And I'm doing this because I don't have a calculator, but technically, you can just plug it into the calculator from the beginning, right? You can do your math 8, and you're gonna be doing d dx. I forgot what the window looks like, but you're gonna say at x is equal to 0, you're gonna put the square root. Actually, you know what? Don't do this because this is gonna take the derivative of the square root. So never mind. Backtrace. Okay. What you could do is do the derivative for x of t individually, right? Of 5 sine of pi t. Get whatever decimal you get. Do the derivative. Do the derivative for the other function of 2x minus 1. Oh, this should have been an x up here. Get whatever answer you get, and then take those answers and plug them in. Plug them into x prime, plug them into y prime. I don't have a calculator. I can't finish the problem with you guys. Which of the following could be the graph of the antiderivative? Since we're looking for the antiderivative, technically this graph is a derivative. And the derivative here is negative, right? From -2 to, it looks like -1.5. And because the derivative is negative, our graph has to be below the x-axis. So, no, I said it backwards. Because our derivative is negative, the antiderivative is going to be decreasing. A is increasing. So it's wrong. B is increasing. So it's wrong. Okay. From -1.5 all the way to 1.5, the derivative here is positive, which means f of x has to be increasing. Looking at my choices, C is increasing, but then it starts to decrease. So C is not the answer. 82. The derivative of the function f is given by that. What is the minimum value? So what I can do is I can go ahead and graph my derivative. Keep in mind that we have a window, right, from -1 to 1. And I don't have a calculator with me. I'm going to remind you, so everything I'm doing here is just speculation. So from -1 to 1, let's just say my graph looks like this. This is completely random. What you need to do is you need to find the critical points. You need to find when the derivative is equal to 0. So in my random example, this would be a critical point. This would be a critical point. And that's it. So going off of my random example, no, you know what? I think I remember this question. I think I had a couple of your classmates ask me about this question. And if I remember correctly, I think the graph actually looks a little like this. Just something like that. From -1 to 1. So let's ignore this. It's kind of a tricky question. That's why it's kind of good that it's coming back to me. So since my derivative is always positive, that means f of x is always increasing. f of x is increasing from -1 to 1. So if f of x is increasing, we can assume it looks something like this. And it could be increasing in many different ways, right? But wherever you start, just make the function increase. It doesn't have to look like that necessarily, but this function is increasing from -1 to 1. So which of the following is the minimum value? Well, the minimum value would be f of -1, because the starting point would be the lowest value. If your function is always increasing, the starting point is your lowest value, and the end point is the maximum value. And that's because f of x has a positive slope, right? You graph the function, and you're going to get something like this. So the minimum value is f of -1. Okay, number 82. We have the base of a solid bounded by the graph of sine. The solid has cross sections that are rectangles of height 3. Okay. They're perpendicular to the x-axis, so we're doing cross sections like this. Which of the following is the expression that gives the volume of the solid? Well, the volume is going to be the integral from a to b of the area of the cross section. And because we have rectangles, we have base times height. My limits of integration seem to be from 0 to 2. Every single line that I did over here for my cross sections is the base. It's the base of each rectangle. So the base is sine of pi over 2x. The height is 3. So the answer is A. When you're doing volume of cross sections, you're going to have to know the formula for area of shapes. A rectangle, a square, a triangle, a semicircle, anything. Because whatever area that cross section has, you're going to integrate that and you're going to get volume out of that. Okay. Find the integral from 1 to infinity of g prime of x dx. Well, the integral of g prime is g of x, because that's its antiderivative, evaluated from 1 to infinity. Actually, you know what? Let me show you a better notation. So we're going to do the limit as b approaches infinity of the integral from 1 to b of g prime of x dx is g of x evaluated from 1 to b. And we're still doing the limit as b approaches infinity. So then we have g of b minus g of 1. And the limit as b approaches infinity for g of b is 4, because we have it right here. Minus g of 1, which is 0.5. The answer here, 3.5. Okay. The graph of f is shown. The function g is the antiderivative, well, the integral from 2 to x of f of t dt. What is the value of g of 10 times g prime of 10? Okay. Let's go ahead and find g of 10 first. So we're going to do the integral from 2 to 10 of f of t dt. And if I look at my graph, we have a trapezoid. And then we have from 6 to 10, it's kind of weird because it looks like a triangle, but it's not. So I think it might be best if you cut it into a triangle and then a trapezoid. Okay. So we have a plus b over 2 times h minus 1/2 base times height minus a plus b over 2 times h. Now, really careful when you do your trapezoids here because they're kind of slanted. For the first trapezoid, this line segment is A, this line segment is B, and the height is 3. So we have 1 plus 4 divided by 2 times 3 minus 1/2 base times height. For my final trapezoid, this trapezoid is actually oriented in a different direction. We're going to call this A, B, and this is the height, which means we have 2 plus 1 divided by 2 times the height, which is 2. Here, for the first one, we're going to get 15 over 2 minus 2 minus 3. (15 over 2 minus 5). (15/2 minus 10/2, which is negative 5/2). The answer is C. Oh, whoa. hold my horses here. I only did G of 10. I still have to figure out G prime of 10. So first of all, G prime of x is f of x. G prime of 10 equals f of 10. That means that G prime of 10 equals f of 10, that's negative 1. So if I do G of 10 times G prime of 10, I have 5/2 times negative 1, which equals negative 5/2. Oh, you know what? I was actually going to select the right answer, but I didn't even see the negative. Oh, that was going to be a lucky guess. Okay. The twice differentiable functions f, g, and h have second derivatives given above. Which of the functions have a graph with exactly 2 points of inflection? Okay. F double prime of x, we can handle it without a calculator. So if I take f double prime of x and I make it equal to 0, that means I'm doing x is equal to 0, x minus 1 squared is equal to 0, x plus 2 cubed is equal to 0, and you solve them. Okay, we have 3 critical points. But then we have to go test them. And we're going to use the best way to test it. Because, check this out. F double prime, let's say you pick a number less than negative 2. Let's say you pick negative 5. Looking at your factor form up here, if I plug in the negative 5, first I'm going to get a negative. Then I'm going to get a positive. Because negative 5 minus 1 is negative 6. But if you square it, it's a positive. Negative 5 plus 2 is a negative. To the power of 3 is negative. So here we have a negative. F double prime of negative 1. If I plug in negative 1, first I'm going to get a negative. Then I'm going to get a positive. And then for my third group, I'm going to get a positive. So that is also a negative. F double prime of 0.5. That's a positive. 0.5 minus 1 squared is a positive. 0.5 plus 2 cubed is a positive. And then finally, f double prime of 2. We have a positive, and a positive. So how many points of inflection do I have? Just one at x equals 0. Because that's the only point where the second derivative changes sign. So since f is not the answer, we can cross off actually, hold on, looking at my work real quick, this should have been a positive, huh? A negative times a positive times a negative is a positive. So I stand corrected. We have 2. One at x equals negative 2 and at x equals 0. So this one actually checks off. And because f is a part of the solutions, you can cross off A and B. They don't contain f. So what I would do next is, since you're going to be dealing between C and D, the only thing they have in common is G. So I would actually go and test H. But again, I'm going to need a graphing calculator for this. So you're going to graph H double prime. You're going to find the critical points when H double prime is equal to 0. And because you're going to be seeing the graph already, that's basically like your number line, right? As an example, if the graph is this, then you would only have one critical point. The second derivative is going from positive to negative, so that means you would have 1 point of inflection, which means H would not be a part of the solution set. But whatever it is, you can graph it, figure it out. 87. The velocity vector of a particle moving in the xy plane is given by dx dt and dy dt. At t is equal to 4, the position is 2, 1. What is the y-coordinate of the position vector at t is equal to 3? Well, you see how I'm given an initial condition? They're saying that at t is equal to 4, the position is that. So if I want to find the y-coordinate, I'm once again going to have to use this formula. So I want to find the y-coordinate at the time t is equal to 3. My initial condition was starting with t is equal to 4. And I'm also going to be integrating dy dt since I want to find the y-coordinate. The position of the particle, the value of the y-coordinate at 4 is 1. Plug it into your calculator. You get your answer. The function f is increasing on the interval from 1 to 3 and nowhere else. Okay. The first derivative is continuous. Which of the following could be the table of values for f prime of x? Since f is increasing on the interval from 1 to 3, that means f prime of x needs to be positive on the interval from 1 to 3. So let's take a look at our tables. Oh, and nowhere else. So that means f prime of x has to be negative elsewhere. And if I look at my tables, A and B check out, but C and D, they don't check off. We have a positive derivative at x equals 0, which means the function is increasing. But it can't. F of x is increasing only from 1 to 3. So now we have A and B. Okay. The answer here is A, and let me tell you why. When I'm looking at the graph of A, we have the point 1, 0. We have the point 2, 2, and we have the point 3, 0. We also have the point 0, negative 1, and we have the point 4, negative 2. If I draw a graph right here, because the function is continuous, I know my derivative has to somehow connect to this point, the next point, and the next point, and the next point. This graph leaves no room for error, right? F prime of x is only positive starting with 1. Starting with 1 all the way to 3. And we know that for sure because the point is an x-intercept. We have 1, 0, we have 3, 0. But when you're dealing with the graph of B, we have the point 1, 1, and then we have the point 0, negative 1. So there's this space right here where we have no idea what's happening. We just know the function is continuous. So for all we know, we're going to cross the x-axis before 1. And that's going to give us an interval, a small interval right here. Oh, I should do a different color. This interval gives us a positive value, a positive f prime of x. So f prime of x is positive on the interval. I'm going to call this A, from A to 1. And according to the scenario painted by the problem, we can't have that. The function f is increasing only on the interval from 1 to 3. Not before 1, not after 1. So B cannot be the answer. Let S be the region in the first quadrant bounded above by the graph of the polar curve and bounded below by the other polar curve. The two curves intersect when theta is 0.45. What is the area? Okay. In order for us to calculate the area of the polar curve, we're going to go the integral from A to B. Now, when you do polar curves, think about the unit circle. There is a line here when theta is equal to 0, and that line is going to start rotating as theta grows, right? That line is going to start rotating until it hits the dotted line. And that's when theta is equal to 0.45. Now, as the angle of rotation increases, and this blue line, the terminal site, starts to move, look, at some point, it's going to capture this much. It's going to capture this much area. So you're trying to capture the area between the angle of rotation, aka the terminal site, and the curve itself. But as the curve moves, you start to capture more and more area. Look at that. And then you keep rotating the terminal site, and then you get more area. And it gets to the point. It gets to the point where theta is 0.45 radians. And at that point, we're capturing all of this area. So we're doing the area between the terminal site and the polar function, the polar curve. So to find the area shaded in blue, we're going to do the integral from 0 to 0.45 of the polar curve. So the region is bounded above by the graph of r equals cosine of theta, and it's bounded below by the graph of 2 theta. So that's what we're doing, the integral of 2 theta d theta plus. So now that polar curve is done, right? Once you continue to rotate the terminal side, once you rotate it a little bit more, now you're starting to capture the remaining area. But our job is to rotate it and rotate it more and more and more until, if I rotate it all the way over here, we're capturing all of this area. If I rotate it more, then we have all of this area. And as I keep rotating and rotating it, I'm starting to capture almost all of that area. So I basically have to rotate the angle or the terminal site all the way till it hits this vertical line, till pi over 2, in order for me to capture the entire area. So then we're going to do the integral from 0.45 to pi over 2 of cosine of theta d theta. I don't have a calculator with me. Go ahead and plug it in, set it to polar function, and your answer is going to come right out. The final question. We have an infinite series, and it's approximated by P of k. What is the least value of k for which the alternating series error bound guarantees that S minus P of k is less than 3/100ths? Okay. The alternating series error bound. The formula is S minus S of n is less than or equal to the absolute value of the next term. And this is the maximum possible error that we're going to find, right? This a of n plus 1, we're trying to make it be less than 3/100. We're going to have to show that. So normally there's a value right here for k, and we're saying, oh, add up the first 6 terms. Well, according to the formula, the maximum amount that the sum of the series is going to be off by is going to be by the value of the next term, the 7th term. So, okay, again, we don't know how many terms we have to pick, right? We know it's k. So if I follow my formula, I'm just going to go ahead and use k plus 1. Here, maybe I should show you with a number first. Let's say k is 3. My question would be, what is the alternating series error bound question mark? So if I was supposed to use 3 terms, I would do S minus S of 3 is less than or equal to the absolute value of A of 3 plus 1, which is basically the 4th term. And if I'm using the 4th term, I would go to my series and I would plug in the 4 into the n. 2/4. I can ignore the -1 because I have an absolute value. So 2/4, which is less than 1/2. That would be my alternating series error bound. I would be off by less than a half. So just like that, we're going to do the same thing. But this time we don't know what k is, right? So we're going to keep it as k. So we're going to have the absolute value of a of k plus 1. And that's supposed to be less than 3 over 100. That's going to be less than or equal to 2 over k plus 1. Oh, I'm going to ignore this one. 3 over 100. Okay. I got to solve for k. So we're going to cross multiply. 200 is less than 3. K plus 1. 200 is less than 3k plus 3. 197 is less than 3k. And if I divide it by 3, 3 goes into 19 6 times. There's a remainder of 1, 17, 6. No, that would be 18. That would have to be a 5. A remainder of 2. Point 0.6. Okay, double check it with the calculator for me. So k would have to be greater than 65.6. So clearly 65 is not going to cut it. So we have to go up, right? We have to go to the next whole term. So 66. All right, that covers it. That is all 15 questions for the multiple choice part B. If you have any questions about anything that I said, if you see me make a mistake, just let me know. Bring it up in class and we'll discuss it. Thank you very much, ladies and gentlemen. Have a good day.